Okay, so because I need to give a I need to let your parents know because I've been asked from one of your parents, so both of your parents, so I need to give a report what you guys are doing, what we are doing, guys, what I'm talking.
Yeah.
So make sure that we are in the right path, make sure that we should not cheat ourselves, we have to be honest when we do the homework, and we have to learn so good and be a great programmer. So today I'm going to talk about um, so okay.
Yeah.
Okay, let's data structures and algorithms. Okay, so my first question is, if you want to build a house, so if you want to build a house, what do you guys need?
Blueprints like class.
Yeah, so in the programming, I'm asking in general, what do you need? Um, what do you need in general? So, okay, so let's go and do this one. Okay, so if you want to build a house, what do you need? You need bricks.
Yeah.
You need you need bricks and wood. This is called bricks, and you need plus wood and iron, something, right? Whatever you need. These with this, what do you need? You need a home building instructions. Home building instructions. Okay, you need a bricks plus wood plus iron plus some home building instructions to make a house, home, right? Nice home. At the same time, at the same time, good programmer, good programmer also need what we need. You need data structures. Those data structures are like the arrays, linked list, and graphs. This is an example. Okay, plus code instructions. Okay, so then you will build a nice applications. Okay, so okay, data structures are building blocks or raw material for any software programs. This is very important. What are data structures? Data structures, STRAC2 CTU. Data structures are building blocks or raw material for any software programs. Okay, data structures are building blocks or raw material for any software programs. So, and also one thing, one cannot become one cannot become a good programmer without understanding of data structures, without let's say sound understanding of data structures. Okay, so data structures are building blocks or raw material for any software programs. one cannot become a good programmer without sound understanding of data structures. Okay.
Okay.
Okay. So because when you build a house, you need a instructions how to make a house. Let's say um, the good example of the programmer. So if you want to make a window, let's say if you want to make a window, so if you want to make in a window, okay, if you want to make in a window, uh, if you want to make in a window, what do you take? Do you take bricks or do you take wood?
You would take to make a window.
Yeah,
You would need something else. You need glass.
glass. No, if you make, yeah, glass inside, but if you want to make a wood window, let's say,
Oh, I see what you mean.
yeah, if you need to make it, at least you need a wood on these four sides, right?
Yeah.
So you don't take this one, right? You take this wood, right?
Yeah.
Same way, programmers also uses data structures. So their containers storing data in specific memory layout. Data structures also like a containers, like a variable. They store a specific information, specific memory. Let's say one example. Let's say store Apple stock price for 5 days and answer. Let's say store APPLES Apple's stock price for 5 days and answer. Okay, so here there is one thing here. um, first question, what was the price on day 1? Okay, second question, okay, so what was the price on day 3? What was the price on day 3? Okay, so how do we access? We use a list. So we say, let's say we say, how do we say? We say stock price, stock price, stock price is equal to, we will have some list. So let's say 298, 3005, 320, 480. Okay, so if you want to access the first day of stock, how do you guys access?
To access the stock, you have to like find out the price and then like buy it, right?
Yeah, we have the prices here. Stock price is equal to
Oh, I
298,
see.
305, 320 and 480. So how do we access in the list? If you use a list,
We do we put down like a function, like a stock function?
no, so because it says day 1 and day 3, what will be the day 1 price in this list?
It would be 298, right?
298. So what will be the day 3?
Day 3 would be 320.
320.
Yeah.
Yes. How will you access these values? How will you get this one? Stock price on day 1.
Stock price on day 1, you would just look at the what's in the brackets, right?
Yeah. So how do we access? We access of stock of price, price of index of what?
Day 1.
Yeah, day 1 of index what? In order to access the day 1 price,
Oh, the
index of,
stock.
yeah,
day
in the
1 price.
stock, what will be the index here? What goes here inside?
298.
Nope. That is the
Oh,
value.
really?
This is the value. So I'm asking what index goes to here to get a 298.
The variable.
This is the variable stock price.
Oh yeah.
So what will go here in order to get this value? So we discussed this one many times.
Uh, hmm.
would it be like 0, 1,
Yeah.
2, 3?
Yeah.
Oh, I see. I see.
0. That's great. That's great. So that's the reason what I said is practice, 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 practice. I promise
Yeah.
you, if you practice everything, if you sacrifice time to practice lists, tuples, sets, dictionary, if else, while loops, for loop, function, lambdas, arrays, class, object, inheritance, polymorphism, dates, math, scope, modules, so you will do great. You know, you will do great. So we will talk this one later. First, we are here. So stock 0. What will be the output here? Stock.
298.
Yeah, the stock price day 1, right? Price on day 1.
Yeah.
So you will get a 298. So next, what? How can we access next one? Stock price. What will be the index here for the day 3?
It would be 2.
Yeah, it would be 2. Then you will get this value.
Yeah.
Makes sense. These are
Yeah.
called a data structures and algorithm. So we use for this one the list. Okay, we for this one we use for a list. So I'm going to open one more here. X. Okay. Hopefully, how do we get open? Export. Okay. So. Um, I don't know how to sign in. So anyways, next, so that is the only one thing if you want to access the price, right? Let's say um, store apples, APPLES apples stock, store apple stock, price from March 4 to March 7 and answer. And also I sent you guys Visual Studio and how to download. So we will talk later. So here, so it says store Apple stock price from March 4th to March 7th. Here it says question is what was the price on March 7th. The same question here. What was the price on March 4th, March 3rd, right? So if you want, see here we want to have a price and value, price on March 7th. So how do we, here we need to have a, so there is two things here. What are the two things? What are the key point?
Sorry, say it again.
Here there are two things you have to find. So first one is, so you see the store Apple stock from March 4th to from March 4th to March 7th, right? Okay, but we have asked only two questions. What was the price on March 7th? What was the price on March 3? So you have, let's say you have stock price. Okay, here we have March 4th 298. Let's say March 5th 305, March 6th 320, March 7th 301. So what do you say if you have, what kind of data structure is this? We already discussed.
What? This is not integer. Index.
No. So what is the data structure? What kind of data structure is this?
Oh.
You have two things. If you have two things, what kind of data structure it is?
Two things. I thought I tipped my tongue.
Is it
It's not tuple. It's
Oh.
not list, because list, tuple, set as only one thing. Let's go back here. So these all one things. If I go here, what is this means?
Dictionaries.
Dictionary. So we discussed dictionary last time. You guys remember?
Oh yeah.
What does dictionary has?
Like multiple like data types.
Yeah, so multiple values. So there are two things I mentioned in dictionary. Anyone has clue?
I forgot.
That's okay. So we need more practice. So dictionary has two things, key and value. Yeah, you remember key means, let's say if I
Mhm.
use baptism, value means what is the definition of the baptism? You know,
Yeah.
Yeah.
that is the value. That is the see, key is March 4th, value is 298. So that's the reason we have to repeat. So do you guys want me to stop DSA, or you want me to go to repeat any of these questions? Python, the beginner Python things.
I think you can move on, Landon.
What do you
Yeah.
think, Randon?
I think you can move on. Yeah.
Yeah. Okay. So question is, we have to prepare. So now stock price. Stock price. Now if I need March 7, you have to pass the key. This is called key. March 7 key. Then you will get the price. What will you get? March 7 301. Stock price March 3, you will get March 3 price. March 3, how much we have? So we didn't have March 3, right?
Yeah.
So we have March 4, but we don't get, because if there is no March 3, we don't get. So now what we have, there is a one thing, we will add those things. So that's what we are going to, now we are going to learn about those stuff, how we are going to do it. Okay, so DSA. So okay, data structures and algorithms. The one important thing is uh, so okay, data structures and algorithms. So data structure is about how data can be stored in different structures. What is data structures means? Is about how data structures is about how data can be stored in different structures. Do you understand?
Yeah.
Okay, which means data structures are like a variables, containers, store information. So next, algorithm is how to solve different problems, often by searching through and manipulating data structures. So theory about data structures, algorithms help us to use large amounts of data to solve problems efficiently. So if you come here, what are data structures? A data structure is a way to store data. Okay, we structure data in different ways depending on what data we have and what we want to do it with. So that's called a data structure. And algorithms means going step by step process, solving problem. An algorithm is a set of step by step instructions to solve a given problem or achieve a specific goal. Okay,
Okay.
for example, a cooking recipe written on a piece of paper is an example of an algorithm where the goal is to make a certain dinner. These steps need to make a specific dinner are described exactly. First, how for algorithms you have to write a recipe. Okay, fried fish recipe. First, cut potatoes. Second step, leave in water for 10 minutes. Dry the potatoes. Boil potatoes in hot oil at 300 Fahrenheit, 160 Celsius for about 3 minutes. So, this is called a step by step process. Algorithm is a step by step process. So this one is the step by step process. So okay, what is the data structure means?
Step by step process.
That is the algorithm. Data structures means like a container.
Oh.
how data can be stored in different structures.
Yeah.
So the algorithms is about how to solve different problems, often by searching through and manipulating data structures. Theory about data structures and algorithms helps us to use large amounts of data to solve problems efficiently. Okay.
Okay.
Okay. See, data structures is like a container stores information in different structures. Algorithm is a step-by-step process. Algorithm is a step-by-step process.
Step-by-step process.
For example, making a making a fried recipe. So these are the step by. First step is cut potatoes. Second step is leave in water for 10 minutes. Third step is this. Fourth step is this. Because algorithms are step-by-step process. An algorithm is a set of step-by-step instructions to solve given problem or achieve a specific goal. Okay.
Okay.
A cooking recipe written on a piece of paper is an example of an algorithm where the goal is to make a certain dinner. The steps needed to make specific dinner are described exactly. When we talk about algorithms in computer science, the step-by-step instructions are written in programming language, and instead of food ingredients, an algorithm uses data structures. So data structure అనేది what is data structure? Data structure is kind of a container stores information in different structures, right?
Yeah.
Algorithm, what is algorithm means?
Shoot, I just had it.
Is it just simple meaning is step by step instructions to solve a problem.
Okay.
For example, what are the algorithms? For example, any recipe like here, fritters recipe. So first cut the potatoes, leave in water for 10 minutes, dry the potatoes, boil potatoes, and cook the potatoes. Something, you know.
Yeah.
That's so. An algorithm is a set of step by step instructions to solve a given problem or achieve a specific goal. Okay.
Okay.
A cooking recipe written on a piece of paper is an example of an algorithm where the goal is to make certain dinner. The steps needed to make specific dinner are described exactly like this. First, when we talk about algorithms in computer science, the step by step instructions are written in programming language, and instead of food ingredients, an algorithm uses data structures. An algorithm uses data structures. So algorithms are fundamental to computer programming as they provide step by step instructions for executing tasks. For executing tasks, an efficient algorithm can help us to find the solution we are looking for and transform a slow program into faster one. To study algorithms, developers can written better programs. This is the main key. Why do we study algorithms? Developers can write better programs. Okay. So next, data structures together with algorithms. Data structures and algorithms go hand in hand. Data structure is not worth much if you cannot search through it or manipulate it efficiently using algorithms. So, and the algorithms in this tutorial are not worth much without data structures to work on. Make sure that data structures and algorithms go hand in hand. What is data structure means?
Like it's like different types of datas,
Okay.
right?
Yeah. So data structures is about how data can be stored in different structures.
Yeah.
What is a data structure?
How data can be stored in different structures.
Yep. What is algorithm?
It's like a step-by-step process of doing something.
Yeah, it's a step by step process. That's good. Example?
Like cooking a recipe when you're cooking a cake.
Yeah, cooking a cake, making a cake. So you take steps what to do, how to do. So you do one by one. So data structures together with algorithms. So data structures and algorithms go hand in hand. A data structure is not worth much if you cannot search through it, manipulate it efficiently using algorithms. So without data structures, algorithms, so it's not worth much. So and algorithms more important, not more important than data structures, or data structures is not more important than algorithms. Both are important. Data structures, DSE is about finding efficient ways to store and retrieve data, to perform operations on data, to solve specific problems. To understanding DSA, you can decide which data structure or algorithm is best for given situation. Okay, so because everyone can write a program, right? Anyone can write a program, but good programmers write a efficient code. Make programs that run faster or use less memory. Okay, make programs that run faster or use less memory. Understand how to approach complex problems by solve them in a systematic way. So one important thing is, if you don't practice programming, if you don't implement see, let's say if we have class of 3 hours, you have to study 6 hours. That way you can understand.
Yeah.
Okay, so anyone can ask you this question: where is data structures and algorithms needed? Data structures and algorithms are used in virtually every software system, from operating system to web applications. So these are the important points for managing large amounts of data, such as in social network or search engine, for scheduling tasks, to decide which task to computer should do first, for planning routes like a GPS system to find the shortest path from A to B, for optimizing process such as arranging tasks so they can be completed as quickly as possible, for solving complex problems, from finding the best way to pack a truck to making a computer learn from data. So DSE is fundamental in nearly every part of a software world. So DSA, what is DSA stands for?
What does DS stand for?
Yeah, DSA.
Is it data structures?
Data structures and
algorithms?
yes, there you go. So can you read this point?
Yeah.
Data structures. DSA is, can you
DSA
read?
is fundamental in nearly every part of the software world.
Okay, so those are what? Can someone read these points?
Operating system, database system, web applications, machine learning, video games, cryptic systems, data analysis, and search engines.
Okay, so in order to do this one, what do we need? DSA fundamental near every part of the software world. So then only we understand these all.
Yeah.
Make sense?
Yeah.
Yeah.
Okay. So so makes sense, right?
Yeah.
Okay, so why do we need DSA?
Because it's compatible with like it's used in a ton of like softwares and stuff. It's
Okay.
used everywhere.
Everywhere. So without data structures, people can work here, but if you have a understanding of DSA, you will do great in a programming. Okay. So
Okay.
um, that's what we discuss. So algorithm is a step-by-step instructions to solve a specific problem. Data structure, a way of organizing data so it can be used efficiently. Common data structures include arrays, linked list, and binary trees. Time complexity, a measure of the amount of time and algorithm task to run depending on the amount of data the algorithm is working on. So space complexity, big O notation, recursion, divide and conquer, brute force. So we will discuss about all this. Um, the most important thing is we are going to understand big O notation. So okay, so big O notation, cheat sheet. Okay, big O notation. Okay, so this is the time cheat. Big O notation means, okay, big O notation is used to measure how running time or space requirements for your program grow as input size grows. So I'm going to write it down here. um, so make sure that these are all important things. Okay.
Okay.
uh, Big O notation is used big O notation is used to measure how running time or space requirements for your program grow as input size grows. Okay, so big O notation is used to measure how running time or space requirements for your program grow as input size grows. So let's say one example, define foo array of. So this is your method name foo. If your size is size of your array 100, then if the size of an array, what is size of an array means? So you know a list, right?
Yeah.
Size means 100 element. If the size is 100 means how many elements in the list? Anyone can guess how many will be in the list if the size is 100? If the size is 100, how many elements in the list?
Would it be 1?
No. See, I said size is 100 means we will have 101 elements. You know why? Because it starts from 0 so on up to 100. If you
Yeah.
add plus this is 1, this is 100, total 101. So if the size is 100, let's say if the array size 100, how many millisecond it takes? Let's say 2.22 milliseconds, right?
Yeah.
Next one, if the size of an array takes 1000, the size of this takes size is 1000 arrays, 1000 is the size. How many elements in the list in the array?
1001.
1001. It takes more time, which means 2 minutes 30 seconds, 2.30 milliseconds. Okay, so what I'm trying to see, okay, here is the chart. Okay, this is called time, this is called size. Okay, size array. I have a question, guys, for you. So if you use a website, what will you do if the website takes long time to load?
You'd like make it faster.
No, we cannot make it faster, right? Let's see if I'm
Oh,
trying to access one website, but it's going so slowly. It's like zzz, so slowly to open. Then how do? What do you think? What will you do when the website goes very slow?
um,
Most probably
you
you
wait.
won't use, right?
Yeah.
Most probably you don't use. You will get a frustration, right?
Mm-hmm.
Yeah, most probably you don't use, you will get a frustration. So this is a time. Same thing. If you take long time, it's not a good good solution, like good programming, right?
Yeah.
Okay, so this is a chart. Okay, so size array, n is a n means length. N means what? Length. So how do we calculate? Let's say for suppose time equal to a times n plus b. A times n is, what is a n? I just said here.
N, A plus B.
What is n means? N equal to size of the array. Okay.
Okay.
Okay, do you guys remember array? We discussed it in the last class.
Yeah, I remember a little bit,
Yeah,
but not a lot.
so we discussed deep dive into four problems. If you go back to the video and if you go through all things, you will understand. Let's say time is equal to a times n. So a times n plus b. So here b is a constant. What is b?
A constant.
Constant. In the programming, we always drop constants. Let's say first step is, okay, so what you have to do is drop the constant. What you have to do is the drop the constant. Okay, so first one is a keep fastest, fastest, fastest growing term. Keep fastest growing term. So time is equal to a times n. Time is equal to a times n. Second thing is, because you drop the b, then second time is equal to a times n. You always drop the constants. You always drop the constants. Now, so it says drop constants, right? Drop constants, constants. Okay, now you have to drop next time. First you have to drop the b, next you have to drop the a. Next, time is equal to o of n. Time is equal to o of n, right? Time is equal to o of n. Make sense?
Yeah.
So this is called a big O notation. We'll talk about big O notation. What is big O notation? So um, let's say you have a function. Let's say you have a function define uh, get squared numbers. What is your function name? Get squared numbers. You pass here numbers. You passed here numbers, and we have an array squared numbers equal to this. Okay, so squared numbers is equal to empty array. This is called an empty array for n in numbers. For n in numbers. Okay, here square numbers square numbers append times n times n. Okay, n times n, then return this function, return squared numbers. Let's say return squared numbers. This one, return squared numbers. So it's here, if numbers equal to
9% people don't know that if you have
2 comma 5 comma 8 comma 9. Okay, so now then you pass the, when you call this function, you pass numbers, then you will get returns like 2, because it will square, because n times n, 2 times 2 4, 5 times 5 25, 8 times 2 8 64, 9 times 9 81. So here I understand, we understand one important aspect here is one important thing here is to understand what is big O notation, right? So if I go here, big O notation means if the so if this is a time, if the time goes, this is the size. So time and size, okay, these are the big O notations we use. So O of 1 means constant. O of 1 means what? Constant.
Constant.
Constant is excellent and best. O of log n is good. O of n is fair. O of n log n is bad. This is O of n square or O of 2 power n, and O of n factorial are worst, horrible. So n means one loop. N means what? One loop. N square means how many loops?
Sorry, say that again.
So n is a one loop. N is what? One loop.
Okay.
Okay, n is one loop. N square means two loops. N square means how many loops? Two loops. So make sure that, because when you write a code, it does not take, if you have a two loops, it takes a lot of time to execute, right?
Yeah.
Make sure that we always wanted to be here in the excellent mode. So this is the graph. So if you say this is O of n log n, O of 1 is the best case, O of n worst, like better than this one. Okay, not better than this, but this is O of n is better than O n log n. O of n square, O n log n is the better than this. This is worst, this is worst. So horrible is this pink, bad, fair, good, excellent. So these are the color to represent. So let's take a break, then come back because time is going to up. We will have 10 minutes break. Because if you don't understand the basics, those things, if you don't practice, DSA will be super hard.
Okay.
Okay, so see you soon then.